Okay, it started. Hi, everyone. It's nice to see you in the third session that we are organizing with Flock. Thank you so much for this sophisticated sessions and use cases that you are sharing with us. Previously, we had you talked about the agents, and we talked about how to use them and what is the cases. I think the most that we are doing in this session is about the federated learning solutions, demos, use cases that are already in the ecosystem. And that's a great area to explore when it comes to AI and AI advancement, and how to use it maybe in some programmatic agenda when it comes to UNDP, or to how to support the private sector development when it comes to such cases and replicate it. I would give the floor. Thank you, everyone, for joining in this third session. I think it's the last one for this round. We will organize maybe other sessions as well. I will give the floor to Flock, Tiffany, to start also to kick off the discussion.
Thank you very much for your time and for joining us for the third time. I believe this session will be a session related to Flock's product offering. We have done 2 sessions before. One is on basic AI knowledge, and then our founder and CEO also did the agent AI workshop. And today's session we will be dive into Flock's key product, which is Federated Learning Solutions. I will give the floor now to Mo, my colleague, and Vasil for the presentation.
Thank you very much. So I'm going to start with an overview of machine learning and AI a little bit more broadly, because federated learning is a specific kind of sovereign state, kind of privacy preserving way of utilizing machine learning. So I kind of wanted to set the ground first. Just so I'm kind of pitching this right, would it be possible, could I get a quick sort of show of hands in terms of if you are familiar with machine learning, if you've used it before, or if you would like me to sort of, I guess, start a little bit from the basics. It would just be useful to know so I don't waste your time.
Start from the basic. This is what I recommend.
Okay, yeah, that's good. Marta, you have your hand up?
Yeah, I was answering the question if I had used machine learning already.
Oh, okay, fantastic. Okay, so what I will do is I will, so I'll go through kind of some groundwork. Please feel free to interrupt me at any time if there are kind of questions, clarifications that you need. Yeah, let's kick in. So I'm going to share my screen. Here we are. Can you all see that? Perfect. Okay. So I wanted to kick off firstly with strategy. So, you know, a very common complaint with IT folks is that, you know, they try to use the same tool for everything, right? So every problem looks like a nail. We don't necessarily need machine learning for everyone. So, and the other thing to bear in mind is that, you know, we are now in an age where we can use AI agents, large language models, to do a lot of the difficult stuff that we would otherwise need to have asked for specific budget, headcount, you know, machine learning engineers to do, right? So now when it comes to sort of looking at the problem, a lot of it is actually, we're much more kind of heavy on that strategy side. The implementation side, I don't want to kind of underestimate the amount of work required in implementation that's still there, but you are now, more people are empowered to kind of make these strategic decisions because the cost of implementation has gone down. And I will go through some of this later. So I'm going to kick off with strategy. We'll be talking about types of models, how to select data. And I think the most interesting thing, hopefully for us, is that we have created a federated learning exercise, which doesn't require you to have massively powerful data centers. So you can actually run from your own computers and potentially from your phones as well. Presumably you got recently, it might overheat a little bit, but where you can actually participate in a federated learning exercise, and we have a little data set from the medical world to help with that. So I will go straight into kind of the AI landscape first. So I think these are things that you're probably familiar with, but just to kind of position machine learning in the kind of realm of AI more broadly. So AI research has been happening from the early 70s, and a lot of what happened in the first sort of 3 decades was very much on the left-hand side. So AI that functioned in a way that we as humans understood it, right? Business rules, formulas, expert systems. And these sort of systems are very useful where you need kind of full auditability and traceability of every step in a decision-making process. So this is called old-fashioned AI, but it's, I think the term that you often hear in academic conferences is good old-fashioned AI. So like this is still useful, and I think most, we don't really call this AI anymore. We just call this automation. But of course, back in the 70s, that was state of the art, right? And then we have, so this is where cases where we understand the rules, we embed our knowledge consciously into a system, whether through code, through rules engines, and so on. The other side, and of course, what has grown massively in popularity in the past, also I would say, probably 15 years, as we've had greater, CPU capacity, processing capacity, as well as storage capacity, is neural networks. So this is where, rather than us having to understand what's going on, embed the rules, codify rules, the system is learning from data. And we design an algorithm to help the system learn, but often this is data that's beyond our human capacity to kind of go through. And I will talk to some of these through machine learning types in a moment. So you're finding things that we will have an idea that there is some pattern there, but we don't know. And when we are looking for a system to find it for us. And this overlaps quite a lot with data science, and depending on who you ask, data science is, encompasses everything, including all types of AI, and other people might say that data science is simply kind of the first sort of, analysis part. But I think, more broadly, what we're finding is that people will need to learn data science to, it kind of becomes like, if you think about in the late 80s, right? People often didn't do their own typing, right? There would be a pool of typists. You would dictate your document, or you might write something by hand and give it to a typist to produce, right? And then as we started getting used to kind of Microsoft Office, before we used to have, like I used to work for Royal Bank of Canada. In the early days, there used to be a design team that would even produce all of our presentations. If we were going to a client meeting, even some big internal presentations. Now, with everyone using PowerPoint, the expectation is that you sort of do it yourself, right? So when it comes to kind of data science, like we're already kind of, I think, well on that path, where a lot of these sort of data science tools, some of these capabilities are even embedded in the latest version of Excel. They're much more accessible now, and the expectations of our role are changing, where of course we still have kind of dedicated data scientists within our organizations, but now we, in non-specialist roles, are expected to take up some of these skills, right? So broadly speaking, so I've kind of given some examples here, but looking for data. So finding data is a big part of this before we can even start an analysis, and then sort of understanding what the data is showing us, and then figuring out how we can then use that data to help us in the future. And then the final step when it comes to AI and ML engineering is then building systems that then take us out of that process, right? Where we can replace what would otherwise have been a human team or a human intelligence with a system that acts autonomously. So I'm going to kind of move now into kind of strategy. When do we actually need machine learning? And this is something, so actually I will send these slides over to you, because this is a kind of very kind of useful sort of rule of thumb to keep a look at. So I'll kind of start on the right hand side. So if you already know what the rules are, and the rules are robust, they're proven, then you don't need machine learning, right? So if for example, if you have a very simple threshold here, given an example of an income threshold for aid, you're not looking at other factors, then What you can do now is just simply bring up your favorite LLM, write down what your rules are, write down what your data source is, and ask it to produce some code for you to codify that, to turn those rules into a program, right? The other thing is when you don't have enough data to train on. So now machine learning techniques are improving where you don't, like in the early days, you would need like, millions of examples. Now there are techniques where you can learn with very, very few examples. But the key thing to bear in mind is that your data has to be reasonably representative, right? So if you've only got a small number of records and those records are not representative of the problem or the people that you're trying to serve, then you may need to go back to, regular human intuition, come up with, like AI can't guess what is going to happen in the future unless you give it enough information about the condition of the environment you're going into and the problem, right? So until then, you may want to write something manually until you've collected enough data. Now, transparency of logic is a very interesting one. So in my previous role, I was head of innovation for the Royal Bank of Canada. And there are certain processes, regulated processes, especially when you're dealing with things like consumer credit, when you need, of course, and a lot of it depends partly on regulation, but also partly on the risk appetite, of the legal and risk teams within your organization, whether you actually need to provide transparency of logic. Is this something that you want internally? Or there are some organizations, and the hedge funds is probably a great example of this, where they don't necessarily care about transparency of logic as long as they're winning the majority of the time, right? So this is kind of something that you need to think about, because what we often found out in the early stages is that we locked ourselves out of a lot of AI use cases because we thought we needed full transparency of logic. What you really need, and we will touch on this a little bit later, is the ability to show and evidence that you're being fair, and you need to be able to test fairness. That doesn't necessarily require full transparency of logic, because the problem, of course, that you have in machine learning is that fundamentally at the core, it's going to be a black box. You will be able to produce probabilities. You won't be able to interrogate exactly why, in a way, a human would understand a certain decision was made, right? Now, this has a lot of parallels. So, when we look at kind of financial advice, for example, and when there are complaints from customers around, hey, I was asked to invest in this was the wrong thing for me. A lot of these things are backwards looking, right? So you can't, even with it, if you have a human doing this process and it's not automated, a human will often use their memory to respond to you and say, hey, I made this decision because of such and such reasons, right? You don't necessarily know when you are interrogating that particular human whether those are the true reasons, right? But they sound plausible. So that's the other thing that you kind of need to bear in mind also when you're using, when you're thinking about applying machine learning, is sometimes that we often try to apply a higher standard to a machine that already exists in than what really exists in our organizations. So if we are making decisions in our organizations without full transparency of logic, we have to question why we might require that from a machine. Does the machine need to be better than a human, or is the outcome more important than what is actually happening? And of course, we'll talk a lot more about that as we go on. So if you going back to the left-hand side here, so if the rules are too complex or we're unable to enumerate them, we don't even know what they might be, this is a great time to think about using machine learning. There's one example where we are working on with the Latin American Caribbean regional office, where we are looking at microinsurance for smallholder farmers. And in this case, we need to look at crop photos. So, we're looking at satellite imagery overhead. We're looking at photos taken from drones, and we need to be able to understand what kind of crop this is, what the yield might be, if there's a weather event, what a severe weather event, what the damage would be, how to quantify that damage. These are things which are very difficult to write rules for, but these are things where, of course, we have plenty of examples of these things happening. People growing crops, people suffering weather events, where we can show a machine all of these examples, these photographs, this data, and see whether it can produce, understand what those, how to kind of predict those things in the future. Fraud detection was a really interesting thing for us. So this was, Joao and I worked on this for quite a long time at the bank. And what you often find with fraud is that the moment you take some measures, the moment you identify something and you put in some rules to prevent it, the people that you're battling against are reacting to that in real time, right? So they're constantly evolving their tactics. So you could, you would always be lagging, as a compliance team or as a risk team in trying to resolve, trying to prevent fraud issues. But this is kind of where machine learning can really help, where you can keep a system constantly evolving. And also with fraud, there are very few cases, in a realistic kind of fraud investigation setting where at the outset that something is definitely a fraud or definitely not a fraud. What you're really doing in these sort of cases is that you're looking at your human effort. So, you might have 2 or 3 people's worth of time able to devote to a particular problem. If you were to look at every single transaction, that might require thousands of people more than your organization actually has. So what you want the machine to do is not to decide on you for every single case, but is only to make sure that those 3 people's time is used effectively. So you're asking the system to give you a probability of what do I think is a fraudulent transaction, right? In order to ensure that your human effort is used wisely on things that look high risk. So again, you don't necessarily need the system to make a decision. Going back to the whole transparency of logic point we were talking about earlier, right? You just need it. If you're happy to, of course, if you're comfortable enough to do that, you can go all the way and have a system make a decision. But often what we often use it for, especially in well-regulated environments, is to flag things that a clinician, a banker, a compliance officer would need to look at. The other key thing is that you do need to have enough examples to learn from. Of course, we touched on this earlier. Again, when you start the process and you're looking through, you may not have. To give you an example, we had done a small exercise in the Malaysian state of Sarawak beginning of last month. And they were looking at some agricultural use cases, and their first sort of observation to us was that the things that they needed to learn from, they weren't even collecting the data for. So they would be collecting data from scratch, right? Now, this is something to get, of course, it's important to identify early on, because the amount of data you need is not, again, like I said earlier, it's not in the millions anymore. You can learn from relatively small amounts of data. So if you want to do something, if you can start even collecting data from today, you may very quickly be able to reach sufficient volume to be able to kind of start a process. So here's a quick decision guide. So again, I will send you these slides. So this might be something that you can kind of keep to hand when you want to decide whether to use ML or not. So yeah, very simply, if you know what the rules are, and they're well understood by people, there's kind of no debate about them, and you can write them as explicit logic. You don't need ML. I would say you should have enough labeled data, maybe more than 100 examples. But again, if you've got sufficient diversity of data, less than that, it may still be possible. The other really interesting thing is that you don't need to train a model from scratch. So in the exercise that we're going to do today, we are going to train a model from scratch. But you have to think a little bit like, I know we hate management consultants, right? But you have to think a little bit like a management consultant here, right? Because there are a lot of problems which are analogous to other problems. And if you look on, so there's a website called Hugging Face, some of you may be familiar with. There are a lot of open source models published there on Hugging Face. And what you can often find is that there will be a model for something that might be similar to your problem, or maybe in another country, or for example, so I'll use another UNDP project we have with Rwanda as an example here. So we are trying to train a model to accurately identify gorillas by their faces, right? And this is for us to be able to pinpoint exactly where a specific gorilla is in a national park, because of course they're very highly intelligent animals. We can't put like a tracking collar or something on them. So within the national park in Rwanda, the Volcanoes National Park, there are static cameras. Yeah, so when an animal passes by, you can capture their photograph. Now, gorillas can be recognized by face, so the human trackers are able to do this, right? Now, there isn't, as you can imagine, a model that trained to recognize gorillas by face, but there are loads of models trained to recognize humans by face, right? So you can take an existing pre-trained model for a similar species, I guess, and then you will have less, of course, data on your gorillas, but you can find, because it's a similar enough problem with similar looking data, you can essentially use these open source models rather, which have done 95% of the work for you, and you only need to collect a little bit of data to make it usable for your use case. So going back to kind of what the whether you should fine tune or whether you should train from scratch. So the key thing is, of course, fine tuning is much faster. You will reuse existing knowledge from either another research team or whatever organization has created that model. And you can start much quicker, and you don't need to collect as much data. But of course, you need to find analogous problems. Sorry, Louise.
I find this really interesting. Just a quick question, and I don't expect you to have like the answer to it. But what I mean, so we work obviously a lot with governments, but also other actors, and in my case, a lot of municipalities with limited data. And it's one thing, of course, to say, okay, here's the problem. Which one should we use? Like the traditional way, or should we use machine learning? But in many cases, we don't even get to that point, right? They will never even, they don't really understand, like they know what their problem is, perhaps, but it's not framed in such a way that you could say, oh, there's another model for people, we can apply it now to gorillas, They even getting to a point where you understand that this could be useful. Do you have any, tricks or recommendations for us in terms of how we can even get to a conversation of, could this problem be solved with machine learning, or should we look at other models? Do you have, just to kind of help, I'm sure you've had these conversations many times, so any insights on this would be useful.
The only thing that I think has worked for us in the past, and I know you've done some of these things as well before.
Yeah, I was gonna jump in if it's possible.
Yeah, please.
Yeah, I think actually go back to some of the point we were reviewing the last cohort. I think first port of call, look at country office have similar challenge. Maybe some country office, some geolocation, they will have similar problem, and they will have data set that you can already start building things on. So that's the first thing I would have gone to. So
so I'm not so worried about country offices, because these are UNDP, educated colleagues. Oftentimes we work with the public sector that are not so, let's say, plugged into these types of modern technology, if I put it nicely. So it's too big of a question. Maybe it was stupid to bring it up, but I just wanted to pick your brains a little bit, because it is challenging. It's challenging to even get to a conversation around these topics.
I mean, we have these issues actually. So the one thing that I find that's worked well is just by showing examples, because I really with this again, in my old role in the operations team, 50% of my role was actually basically applying AI to operations, right? And these are all intelligent people, but of course they were not familiar with the technology and how to exploit the technology, what it can do, what it can't do, what it's reliable on, and what it's not. And you can do plenty of courses for them, but it won't necessarily sink in. The only thing that worked was showing examples. So and again, obviously it depends on the level of engagement, but I would always have the team go and do the day in the life, right? Of course, and the organization has to allow this, but I was fortunate enough to be able to take my team members. So I would take an AI engineer and I would embed them in the operations team. I would say, look, your job is not AI now. Whatever the operations team is doing, taking customer calls, whatever it is, you're doing it, right? So they obviously learn, on the ground, what the team is doing, but they also then learn the ability to actually communicate with those operations colleagues, because they, they will have then a shared language of dealing with those customer problems, right? Certain types of knowledge banks that they go to, different ways of addressing it, different ways of kind of reframing problems. And you really need an insider, I think, because, again, you can show examples, and I think examples probably take you 60%, 70% of the way there, because people will see things and they'll be like, oh, right, maybe we've got a similar problem. But I think the other thing that you really do need is that internal advocate. So if you have the ability, like we definitely didn't do enough of this. Like this would happen relatively rarely, and you would need the executive support to enable this to happen. But we would always try and take someone technical and put them into one of those, embed them with one of those teams. And the important thing to ensure is that when they embedded in those teams, they were not just treated as technical support, that they were actually doing the work, taking the calls, going to the field, whatever was required, right? The other thing that can sometimes be helpful is that sometimes in these operations teams, again, like you kind of need the management support to enable this to happen. But if there is someone with a bit of technical knowledge or interest, perhaps, you can take them out of the technical team maybe for a few weeks, and then train them up and drop them back in. The advantage of doing that is that, of course, they will have well-established relationships with those operational teams. So, they come in with a bit of additional knowledge and they're able to then become your partner, right? So no easy answer to that question, but I think showing examples does go.
It was helpful, actually. It's helpful. Yeah.
Also, I spent like 10 years working in the aerospace, which is not always the most technological advanced sector. Sometimes you can start by area, like pocket of your process that's relatively data rich and iteration faster, for instance. So typical example is like customer service, because people call and you take their call, naturally you have data. You have some data to start mining on. So those some of the spaces you can actually have like pocket of potentially create some fast proving use case that can impact some KPI that matter to the middle or higher management. Certainly for my personal experience, it's more important to get through to the senior/middle management, not the top one, because top one you always say, oh, do AI. And then it's the middle management say, oh, we already struggle with time and space and resource, and you certainly want us to do AI. Where do we go start? So usually it's easier to if you have a use case that impact on their individual departmental or personal KPI.
When you find these examples, like you have to really over communicate. Like it doesn't matter how small it is. Like if it helped one person, save 2 days a week or so, then like you really have to over communicate it across the organization, because people are, of course, attracted by success. People are always attracted by doing less work, right? so I think that's the other thing, is that examples, but also you really, what we often find is that like people forget so quickly. Like we'd show a team something 1 month and then you'd go back the next month, and obviously they're very busy with their operational work, so like everything had been lost, right?
There is also a thing of timing, because for organization and large governmental sector, you have this thing called budget cycle. Make sure you have something ready at the right beginning of the budget cycle before the cake get cut. That's just, hand-on experience.
I had one more comment, because obviously there will be pockets where you have more data than others, and I think it makes a lot of sense to start where you actually have the opportunity to leverage the technology to its greatest extent. But there's also this trade-off between the sensitivity of the data, right? And you don't want to test something for the first time if that's sensitive data, for example, personal data or anything like this, especially if you don't have the frameworks in place around data management, or how you don't have an AI maybe strategy, etc. Do you have any recommendations here? Because in the consultation I've done, a lot of the time people say use the least risky data possible when they do it for the first time, just because even if, excuse my language, they fuck it up, that will not destroy or let's say
Yeah.
put any blockers on in the way to actually doing something bigger later on. Any feedback on this or recommendations would also be appreciated.
Yes, I mean, I really struggled with this before. So I think what you often find, again, similar with the bank, like we had to start on the most like low risk stuff. The problem with starting on the low risk stuff is that your impact is also very low, right? So, you do a really good job and it barely moves the needle. No one's interested in expanding it, right? And I think this is actually where federated learning helps, right? Because usually what always happens in the sort of the first stage of these sort of exercises is that you identify where you get your data from, and then you have to move or copy all that data to some sort of central space where you can work on an AI project or do your data science, right? The advantage with federated learning is that you leave the data where it is. This, of course, requires a lot more collaboration from partners. So what we found out, for example, with the Malaysian government last month, was that they had applied, so they had this, we were running it on their own machines, but because their own machines had been configured in such a way that people weren't normally doing this kind of advanced work. So even though we weren't moving the data from the machines, there were lots of kind of, I guess, like security restrictions on the machines that prevented machines communicating with each other. That kind of prevented kind of federated learning from working until I think we took about half a day just to kind of fix those things, right? But again, so with sponsorship, I think you don't need to ask people to take as big risks with federated learning, because the key thing is that the data stays where it is. The other thing to bear in mind compared to where we might have been 4 or 5 years ago is if you wanted to do a big, for example, machine learning exercise with photographic data, then you would need, kind of substantial hardware, right? So, and that would often be the need for you to then take that data from whoever was collecting it, whatever agency, and put it into a central place. Now, for example, if you have got like a relatively recent MacBook within the last 3 to 4 years, you've actually got sufficient capacity to do some serious machine learning work on the device itself, right? So that's the other thing to kind of bear in mind, I think. And I think a lot of people, what we found when we talk to enterprises is that they don't know that this is possible because they have learned AI from vendors, the likes of Amazon and Microsoft, where the assumption is that you have to adopt cloud, you have to move your data to cloud, and then only you can do everything. And yeah, sometimes it's a bit of a kind of a gap when we say, hey, no, you don't need to do anything. You can just leave your data on your own computers, right? Even in the field. So if someone has collected data in the field on a laptop, as long as it's a reasonably recent laptop, they don't even need to send that data back to base. They can do ML work right there. So you can really reduce. So rather than looking for the lowest risk data, which then means that your work often becomes meaningless, you can simply reduce, I suppose, the footprint of where that data goes. And in the best cases, you may not need to move the data at all. So you can do a small experiment with one office where they keep everything on site, right? So yeah, so we have a toolkit specific to to enable that. And the other thing to bear in mind is that a lot of I think the knowledge often hasn't caught up, but we're in a very different space to where we were 5 years ago, where you can do a lot without buying like a $5,000 machine, right? What I'd mentioned here is that I was talking about fine tuning, where you find, an analogous problem, find someone who's trained a model for that, take their model, and then you'd fine tune it with a smaller amount of data. But you can also build models entirely from raw data. And I wouldn't, don't be put off if you don't find an existing model or an analogous problem. Because as I mentioned today, we mentioned earlier, things are a lot different than where they were 5 years ago. If it's depending on how complex the problem is, you might not need massive compute to train your own model. And you will find out in today's exercise, you're all going to do it with your own computers. So it's not, don't be put off. It's if you don't find an analogous problem, I think it might mean that what you're doing is even more novel and then even more worth doing. So I will. We're going to quickly kind of go into to the actual exercise shortly, but I wanted to kind of give you a kind of quick overview of the different model types. I think if you are familiar with statistics, you might have come across some of these things already. Linear regression, this is often used, to kind of predict a price or give a sort of a yes/no. These sort of models can be fine-tuned as well. Decision trees, these can't be fine-tuned, or at least not with the techniques that we have at the moment. But this is like when you're looking at a large set of data and trying to outcome data and trying to figure out what factors have influenced it. And we used to use this a lot actually in fraud monitoring, where we didn't know what was causing a particular series of fraudulent transactions, and we were trying to kind of pin down what might be moving things. Now, neural networks, this is where you're looking for complex patterns, and we're going to train one of these models in our example today. Of course, large language models you're familiar with, as I'm sure you would have all used them by now. I wonder if someone, I'm going to give you a typical Asian dad example. I wonder if you can tell me what type of model this is. Any guesses?
Is it linear? I think it's no.
Yeah.
Yeah, it's regression.
Can you go back to the first page, the previous page again?
Yeah.
I think the second one, no? No, maybe the first one, linear.
Yeah,
logistic regression.
It's just that you're talking about hours of study, right? Yeah, you're right. Yeah, so this is a regression. And I think we are I was going to talk a little bit about kind of data preparation and stuff, but I think what might be useful now is, well, let's go into the exercise. And then some of this will probably make a little bit more sense once we have started the exercise. So let's go. Vatsal, are you ready to go?
Yes.
Awesome. So we are going to be sharing with you a link, and then you will all be able to join a federated learning training run from your device.
Mo, do you want to spin it up since your screen is already being shared?
Yeah, sure. Okay, the launcher, right? Yeah, that's it. Oh, hang on. Password's not working. What's going on there?
I promise I haven't changed anything. Should I share my screen?
Yeah, go ahead. Shall I stop sharing on my side, and then you should be able to share on yours?
Yeah. Let me know when you see something.
Yeah, we can see it.
Yeah.
Yeah, so we'll do a glucose one and probably just put like 5 rounds.
Okay.
Yeah, and about 6 participants. At least.
Yeah. I think we should have more. Yeah.
Yeah. So we have a pre-selected data set that you can choose from. It has various attributes, like some of them have missing reading, some of them are way too volatile, some have sensor issues, etc.
So what we're going to ask.
Yeah.
Oh, do you want to go ahead and put that link in the chat, or if you're doing it from your phone, you can just scan the QR code.
Yeah, we promise to not crash your phones.
So once you go in, you will need to select one of those data sets. So essentially what we have done, what we're showing here with federated learning, and we'll explain this a little bit more after the exercise, is that you can train a model without sending data to a central place. So in this example here, you're going to select one of those data sets, which is part of the data set that we would need to train this glucose prediction model. And then in your training run, you will only be training with that piece of the data, and then only the changes will be shared with all the other participants. So collaboratively, you will train a model that's seen all the data, but you have done it without sending any data to anyone else. So I'm also going to join as well.
So the use case would be glucose forecasting workshop. Like, are we trying to train this about this example, right?
Yes, this example here is predicting glucose. Yeah.
Okay, good.
So yeah, choose one of the data sets, and right at the bottom, there'll be a button to join live training run.
Mm-hmm.
So I could see I'm number 5.
I think I'm on node 1, proposal, role as proposal.
I think I am node 5. I'm a voter at the moment. I think we've got a few others on.
Let's wait until everybody joins.
I think I'm node 6.
Mine is 8.
Yeah.
I picked something. I can't remember what I picked. I'm just typical user.
Marta, you have a question.
Yeah, I have a question about the learning itself. I have always wondered if the training has to be at the same time in every machine, or if it can be asynchronous. Is that possible for federated learning?
Yes, it doesn't need to happen at the same time.
Okay.
So you could do a run on another device tomorrow, and then you could share the you can share the change
only.
Yeah.
Okay. And is there any requisite on the machine capacity, like RAM, minimum RAM number, or almost, or it can run in any kind of machine?
For this, I think pretty much any machine, like we've it's even phones is fine. Like there's relatively lower for this, but this is simple time series data, right? This is just someone has taken a meal, what's the time, what's their glucose reading. It's very simple. If more complex model, like a vision model, then you might need something a little bit more substantive. For our federated learning toolkit, we have a version for Apple Silicon. So you can, I think for most kind of problems, if you have 16 gigs of RAM and Apple Silicon, you can do everything apart from maybe big LLMs, right? But small vision models, prediction models for time series is absolutely no problem. You don't even need a GPU for. Vision models you can do with a small GPU. So yeah, I would, if you are, I would say like a basic Apple MacBook is probably fine. If you haven't got an Apple Silicon device, then you can do things like this with CPU only on pretty much any machine. But if you're looking for something a little bit complex, like again, vision models, or if you want to train small language models, then you probably will want something that has at least like a video gaming GPU that you can then use to accelerate your training.
Yeah, I'm just thinking about this for our context, given that we work with developing countries, might be difficult to find people that have devices that will match what is needed to train these models. Because of course we are always looking for ways to implement these technologies in developing contexts, and even though we know that many, like most of the people in developing countries have a device, the quality and the capacity of this device is not guaranteed, and so maybe the learning might not be applied. So that's why I was questioning what was the minimum requisite, but I understood, of course, it depends on the model that we are speaking about.
Yeah,
sometimes for these kind of like tabular data, you also need to look at sort of like how big is the data set that you have chosen. Usually, like if you're talking about hundreds of data points, that's easy. But depends on the problem. Sometimes if you have like a data set that's tens of thousands, then you probably need to have like a decent CPU, a laptop, for instance. That would depend. Depends on the context.
I think to give you some context around this example. So the reason that we had built this is so we have a research partnership in the UK with University College London Hospital and Moorfields Eye Hospital. And the specific reason they wanted to use federated learning was that they were unable to share their patient data between hospitals. And bearing in mind, when it comes to things like diabetes and spotting diseases, you are sharing fairly sensitive data. So you're not just sharing kind of just the data about their glucose readings or their scan results, but things like diabetes, for example, there are specific thresholds depending actually on your ethnicity, right? On your genetic makeup. So if you're South Asian, there are you are of course at higher risk, right? So when it comes to actually training a model to be useful, you can't avoid some of the kind of the most sensitive elements of that data, or about the sensitive data about the patient themselves, right? So this is where in a normal scenario, to be able to centralize the data and still have a model that was then useful, taking into account all of those sensitive factors about people, ethnicity, any other conditions, etc., it would make a collaboration pretty much impossible, right? But by using federated learning, we've kind of enabled the hospital to keep data within their own within their own premises, while still obviously sharing weights and gradients. We had a more extreme example of this, which I've just started working on, where the data stays on the patient device itself. And it is for this reason that we had made a very sort of by low cost, I mean low cost in terms of computing requirement, sort of a system that can run on a phone, can run in a phone browser. But of course, this is the UK context where we can probably assume someone has a smartphone within the last 5 years, which is typically able to do this. But yeah, I understand that in other regions where you have things like feature phones, this may well not be possible. The other thing to bear in mind is that of course this is kind of a more, again, like I said, this is like a very sovereign example where the data stays on the patient's device. It doesn't have to be this way, right? So if you can have you can still be decentralized without being like, if you're absolutely decentralized, and of course everyone has their own data, they don't share their data with everyone and they train the models themselves, right? But there is a middle ground where if you have trusted people, like if you have a clinic and there's data within the clinic, people can contribute data there, and you still don't need to send data to a central source, but the clinic can have slightly better compute, right? So rather than like everyone needing to have decent compute on themselves, you can have smaller sort of distributed points where a bunch of patients or a bunch of users all come together, and then you can just have one slightly better device in those locations.
Yeah, that's a great solution, actually. Thank you.
So I think we've all completed the training run, right? And we've got a small post-training console on the right-hand side of your screen, or if you're on your phone, it will be below the status, where you can we've taken some sample data, and I think we can.
Mo, can I jump in to ask a question? I think it's maybe better that we can also explain what are the different roles that's being allocated, right? For example, I'm the proposer for Node 1, and there are people being allocated as participant, a voter, and what are the different functions for these roles in the training?
Yes. So essentially, so your the purpose here is to you're looking to minimize loss, right? Which means, hang on, maybe I should kind of go back in my slides a little bit here. So you start off with a base model that basically knows nothing at all, and you are what we're doing here is that we have held back some of the data as kind of like a control. So after each round of training, we are checking the model to basically see how good it is against our kind of our control set. So a proposer is someone who is, if you are training on your own machine, you will be proposing a new model. So you'll be exchanging your weights and gradients, and you will be proposing. And then the people who are voters will essentially be running that model, seeing how good it is. And then they will basically say, yes, this is something that should be included, or no, this has made the model worse, or there's no improvement here, and therefore like discard these model updates. Now, the reason why we have this system is in a very large network where, let's say you might have thousands of clinics. Now, let's say something has gone wrong where one particular clinic, the data is not being recorded normally, or there's a fault with the device and the data is bad. Ideally, with one of these systems, you want to kind of set it and forget it, right? So it continues training, it continues improving the model. But if you have a participant that for whatever reason is now producing bad data and contributing bad model updates, you need to have a way of identifying that and removing that from the pool of trainers until they have fixed their problems, right? So the purpose of sort of having this we are not assuming that your model updates are good, right? We could configure in such a way that we trust everyone, and regardless of what updates you provided, we accept it. But of course, this ultimately comes down to your organizational design, right? So if you have an organization where there are controls at each local level that is making sure that the data is correct and you trust it, then you don't necessarily need this sort of voting mechanism. You can just say, okay, I trust that each local contributor is making sure the data is correct, and therefore I will just embed whatever they produce. But here we have a control mechanism where someone is basically checking and has the ability to reject something if it's not good enough. Now, Vatsal, should we open the inference now?
Yeah.
Now, I think everyone can do this on their own devices, right? Open hosted inference. So if you go, so basically right at the bottom of your completed training run, I think it's the same on mobile as well, you should have an option to open hosted inference. Now, what that has done is that it's taken the model that you have collaboratively trained, and now you can run a query against that model and see how well it does. What we've done here is that we've prepared 5 different samples of glucose data, and then the model is going to tell you whether there's a high risk that you need to respond to or not. So you can click on one of
it runs locally, so you don't have to send the data outside. So even inference runs locally.
So I can see now the status completed. Should we copy inference URL and then, sorry, I'm not really following. What do we need to do right now to check the result?
Maybe you can show them on the screen. It would be easier.
Yeah. Shall I share my screen, or Vatsal, do you want to share screen?
Yeah.
You can, if you want, you can share screen.
Let me just grab it. Yeah, can you see that?
Yes.
So what we had done is, of course, we had all collaboratively trained this model. Now we have now in this browser, and I guess this should be this case on all of your machines as well. You will have downloaded now the model which includes all of the shared updates from everyone else who was also training on their machine. So now you have like a model which includes everyone else's improvements. And we have prepared 5 samples of data. So bearing in mind, this is all running on your own machine. Nothing is going to cloud here. We've prepared 5 samples of data of basically kind of readings, glucose and insulin readings. And then you can run, the model is running and it will tell you whether, let me see, do we have a low risk example here? Yeah, here we are. So sample 1, no need to worry about anything. It's in the right range. Sample 3, if I run that, it's saying that the patient is at high risk.
Can you stop here? What do you mean by no risk and is at the right range? Which metric should we look at right now?
So no, so what we're basically saying, the purpose of this model is basically to say that is to ask a clinician or give an indication to a clinician that, so if you think about like kind of a busy clinical setting, right? You can't see, you are recording this data, you can't see all the patients at once, like there isn't a doctor or a nurse available to see all the patients, right? So what we are trying to do is to identify, based on someone's glucose readings, do they need insulin? Do we need to deal with them straight away? Which in this case, if it's a high risk alert, it means we need to deal with them straight away. Or in range basically means that we don't need to worry about them now, but you keep an eye, right? So this is kind of like an example of us using, so if we think about it from the beginning, and I'll run through this a little bit more in a more structured way when we go back to the deck, is that we have started off with a bunch of data about glucose readings and what the outcomes were. We have trained a model, and now when we put in a bunch of readings, the model can now tell us, do we need to do, like, is there a high risk, or are we okay, right? So this is kind of what we wanted to sort of achieve, where we had like a complex set of data where we have some, clinicians do have some rough rules of thumb around, when did somebody eat, what is their glucose level, whether you need to worry about it or not. What we have done is that we've taken all of that data, we've trained a model that now can tell us, okay, based on the reading, do we need to worry or do we not, right? So I think what might be useful now is I will go back to the slides, because a lot of the terms I've used kind of explaining this are in those slides, right? So I think this will make a lot more sense kind of once I kind of go through the material. So let me just switch back. Here we are. So I wanted to quickly go through dealing with about training data, right? So the obvious sources are your internal data. The other thing to bearing in mind is that there are open data portals. So Hugging Face we actually found very useful. So in our experiment in Malaysia last month, the government had given us some data for us to work on, but we actually were able to find that so we were working in Borneo, in northwest Borneo in Sarawak state, and we found that another university within Malaysia had collected local indigenous language data sets and they had put them online. So we were able to find them on Hugging Face. So it's quite interesting where you will be surprised how much is out there. So I would keep a close eye on what's out there, because you may not need to go through a massive data collection exercise. You may find what you need. The other key thing with partner data, of course, is depending on, and you see this with collaborations between countries, but you always see this often in the commercial sector, is generally speaking, like when you have a data sharing agreement, you expect the other partner to give you to basically give you whatever data they have, removing any sensitive attributes that they are concerned about. The problem that you often have, which a lot of people don't watch out for, is that partners can make data less accurate on purpose, because they don't want to give away either something commercial about their organization or they don't want to give away sensitive data about their infrastructure if they're a country, the particular capacity of certain power stations and things like that, right? So something that you have to bear in mind when you're dealing with partner data is you need to check, like, is this data actually accurate, or is it a range? Has it been made less accurate on purpose? The other thing to bear in mind when data is often so I dealt with in the bank, we would deal often with profitability and turnover data of private companies. Now, if those private companies were direct clients of the bank, we would of course have accurate numbers, based on, of course, whatever the client was reporting to us. But if we bought data from a third-party vendor, often what we would have is a range. So we say, oh, this company's turnover is between 1 million and 5 million. Now, in a data cleansing process, sometimes what systems might do is pick up a midpoint. So they will say, okay, between, let's just pick 3 million because that's halfway between 1 and 5. But when you are training a model, or if you're using it for any other kind of statistical analysis, it may be inaccurate because, in a pool of 100 companies, maybe they're all at the low end rather than all being in the middle, right? So this is something that you need to kind of watch out for when you're dealing with partner data. Now, cleaning data, now, your big LLMs can kind of do all of this for you. So I probably don't need to spend too much time on this, but I don't think things have changed when it comes to data science, that still the vast majority of time is spent cleaning data, selecting data, finding data, figuring out how to deal with blanks. The advantage that we have now, we didn't have 5 years ago, is that every time we spot a problem, we can go to a large language model, Claude, ChatGPT, pick your favorite, explain your data problem, and it will write some code to clean your data for you. So in most cases, when you're dealing with things like, duplicates or inconsistent formats, wrong types, that's pretty straightforward to deal with now. Of course, inaccurate data, and an LLM is not going to help you there. Like, if anything, it's just going to keep guessing and give you something else. So this is you will, if the other thing to bear in mind is that you do need to kind of ensure that what you're collecting is actually relevant to what you want to use the model for. So you don't necessarily need to clean everything, but you do need to identify what's important and make sure that is accessible. And this comes back to our question of selecting features. Now, going back to what we did in the exercise just now, right? So the data that we fed in included past glucose readings, included how big a meal someone had, right? And insulin levels, right? Now, it's when you are looking at data, you will find lots of stuff that is irrelevant. And bearing in mind, when you are training a machine learning model, especially if you're doing it from scratch, the system that you're training doesn't have any world knowledge. And this is a mistake that people often make when they're taking a process that was human-led and they are training a model to do it, is that as a human, instinctively that the patient's favorite color, their name, what time they woke up in the morning, may not be relevant to this particular problem, right? A model doesn't know that, right? So there is a risk where if you include lots of data that is irrelevant to what you're predicting, that your system may find unexpected patterns to say, oh yeah, someone who wakes up late in the morning is like always going to have diabetes, right? Which could be true for your small cohort because it's right, but may not be something that is really relevant in real life, right? So when you're looking at data, make sure it's relevant to what you're predicting, and that it is representative, right? So like there's no point having 10 very similar examples because you're not really training the model with anything. You need to have variety to ensure that variety of so if we take this medical example, you want to have a variety of ethnicities, communities, socioeconomic levels, people with different diets, to ensure that whatever underlying pattern that you're trying to figure out about glucose is actually found, as opposed to the model latching onto something else. Sorry, Tiffany, you've got your hand up.
Oh, no, I just want to ask about the number of features. For example, I understand that you need to select the relevant features, right? And choose well matters more than choose many. However, if we can choose a lot of relevant features, does it work better for the model training?
But yes and no. Like, it really depends on the problem, right? Because again, machine learning is really helpful when you have really like complex patterns. So if you have lots of data that you think might be relevant, you're not sure what is more relevant than the other, it's better to throw all of it in because it might find something that you're not expecting, right? So when I'm thinking about excluding stuff, like I would only exclude stuff that you know is definitely not relevant. But if you think that it might be relevant, then it's worth putting it in because you will find issues later on when you're actually testing it. So the training exercise that we just ran, so we fed the data in. Obviously, we had pre-selected the data, so you didn't need to kind of upload anything from your machine. You after a training run, you'll make predictions, and then you basically see, okay, based on your control set, how good are these predictions? And you keep training until the machine is pretty close to your control set. And it's important that, of course, it never sees your control set, right? Of course, the key thing that we had showed in the exercise today is that you can train all the models. Well, I suppose apart from maybe decision trees, but you can train both complex models, neural networks, as well as simple models on your own device without using any kind of cloud service. You can, we've got an example actually in our London office where if you're very concerned about security, because of course what happened here is that we all trained on our machines. I'm up in Wales. We had obviously been sharing our model updates across the internet. Now, I think they were through encrypted connections, but they were being shared across the internet. You can do this entirely locally, of course. So again, if you're using Macs, you can use like the AirDrop protocol to share stuff locally. We've got an example in our London office where we have physically plugged machines into each other. So you can run federated machine, if you're very concerned about security, you can do it entirely locally. And I think Marta, you had sort of asked before about about doing it asynchronously. So that's the other thing, is that you don't need to do this live. You could take a machine to one location, you could drive it to another location the next day and update the model that way, right? So if depending on how sensitive the kind of data protection requirements are, you can ensure that you are kind of absolutely secure, right? Some kind of key concepts. I think we talked about some of these things. So this is actually very similar to the way humans learn, I think, right? So an epoch is one complete pass through all of the training data. Now, I don't know. I mean, I don't have a photographic memory, so there's a lot of cases where I will go through a course and and I will only have picked up maybe 20% of it, and I will have to keep passing through to like pick up 5% each time, right? So training a model is kind of like a bit like that. You can pass through all the training data, but you won't have learned everything, and you will have to keep going through to improve your knowledge. Loss, you will hear that mentioned quite often. Of course, this is I think there's an indicator in the exercise that we did today. So as I mentioned before, it's very important to keep a set of data aside that your model doesn't see, so you've got the ability to measure how good that data set, the model's predictions are. Make sure that the data that you're keeping aside is all, of course, diverse and representative, so that it's a good indicator of the accuracy of your model. Now, when I worked at the bank, we used to have a T-shirt that says, this T-shirt overfits, right? Again, very similar to sort of the kind of, problems that we have in human learning, where if you concentrate too much on tests, you will find that people are memorizing particular answers to tests rather than actually learning what those core concepts are, right? So having this diverse training data is really important, but also diverse control data, because there is a risk that you will only, you'll train a model to only answer, from your training data and nothing else, right? So I think I mentioned about this validation set, the data that you set aside, that's key. And you can, of course, you want to, part of the point of doing machine learning is to be able to continuously update when you get new information. So this is something that you kind of need to bear in mind, is that, validation is part of your control to ensure that what you're doing is robust, right? So make sure you're spending some time collecting good validation data. Learning rates, obviously, we had a very simple model and it trained very quickly. But if you were training a vision model or a language model, so the example that we did in Malaysia last month, they had some really high spec machines. I think it was like each $5,000, $6,000 each, but we were training a language model, and I think we were talking. I think there was sort of like a 20-minute kind of between each training run, right? So you want to. The learning rate is important because, again, this is also very similar to things to human learning as well, right? So you go through your textbook once, you learn a little bit of it, and then you are looking at how much you are adding after each kind of pass through the material, right? Now, for efficiency, obviously you want this to be fairly quick, but you don't want to run the risk of overfitting either, right? So that's the other thing to bear in mind, is that you sometimes if it's a complex model and if you're training very quickly, that could be an indication that you're doing something wrong, that your model's not going to perform very well. Sorry, Tiffany, you got your.
Sorry, I have a lot of questions as I'm not very technical. So I understand there will be situations where the model is overfitting and the learning rate is low. And could you explain to us in details or examples, like what will happen? What can you do to improve the training? Like, are you going to change the training method, or like what kind of situation will cause this? What would you do will cause this kind of issues?
This is, I think this ultimately comes from having not really diverse data, right? So what a problem that we often used to have is that you are when you can't collect enough data to train a model, you create synthetic data, right? Now, synthetic data will, you're creating fake data that's based on something that you have that's real. But if that synthetic data is too close to your real data, then you end up having, it's like, again, so if I was to like take a textbook and I would give you another textbook, but it's only like 5 pages are different, but everything else is the same, then you might have read 2 textbooks, but you have not actually gained any new knowledge, right? Because the second textbook is exactly the same as the first, maybe with a couple of small changes, right? So this is where kind of when it comes to data collection, you really do need to ensure that you have sufficient diversity, because what you will end up having is a case where where your model is only useful in like a purely academic setting where you've trained it, you've shown it the result, but the moment you put it in the real world and something is actually different, like it messes up, right? But I think I don't know, Ifan, if you've got any other recommendations, but the only thing I can think of.
First of all, I would say when you talk about whether a model is good or not, it's accurate or not, you have some sort of like mental baseline. Let's say number one mental baseline is random guessing. You just randomly guess a number on any given data point. What kind of accuracy you will have in those situations? That's one baseline. Let's say if you just do like 1,000 random guess on one data point, your accuracy will converge on some sort of like non-sensible value. Usually it depends on, it's similar to the flip of a coin. So when you have a model that's learned, you expect that to be better than random guessing. So that's the most basic scenario. Secondly, in medical case, very often you have best case, sort of like best method, some sort of rule-based method of come up with classification or value. So these, if you work with like doctor, they can always provide those. It's to compare your model against those value. So like best practice value, rule-based value. Sometimes it's just a median of medium or mean of value, for instance, of certain demographic distribution. You first of all compare against those. So you would hope your machine learning model, given all these sophisticated method, given all these attempt to collect data, will perform better than those. That's where at least you can start to claim the benefit of using machine learning models. And beyond that, we are starting to venture into the soft like data science experiment and experimentation control, because there you're starting to think about whether you have some kind of a hold-out data set where you will use to test your model accuracy against. So there you can start to measure in a more meaningful way, overfitting, underfitting. Typical method of just in a pure machine learning sense to increase model would be you can train on more epoch. You can train on more data. You can train with a lower learning rate, although personally, I don't usually do that. Usually within the first 3 methods, you already squeeze 75 to 80% of the gain out of those kind of potential gain.
And the learning rate, you can set it up by yourself.
Usually,
so you can decide
want
which learning rate.
someone with technical knowledge to do that. Yeah, you want someone with technical knowledge to do that. I mean, federated learning have these underneath the hook of this method called averaging. It's basically averaging on either the model level or the prediction level of the values. So that in itself is a kind of ensemble learning, and that has the benefit of sort of like making your decision behavior a little bit more smooth. So you hopefully will have less sort of like outrageous prediction. So that's just a mathematical properties of doing averaging. So this is some of the go-to method to do that. I mean, a lot of in a medical situation, I'm sure in also a financial situation, very often a lot of work would have to go to whether your data is representative to your target population. So I would say if you collect a data set that's based on white male college student American in the US, and then you apply it on maybe some African country with very, very different demographic, then maybe not the best practice. So you need to find a way to counterbalance that.
We will have some specific examples around this actually when we talk about the responsible AI sort of checklist. So I was going to kind of run you briefly through how federated learning works. So in a traditional setting, what we would have done is that all those 12 data sets that you saw in your application, in that exercise we just did, they would have all been shipped off to one central machine, and we would have trained everything there. What we've just done, so each one of you has been one of these nodes here where data stayed on your local machine, and the model updates have been shared with each other. Now there is a way to run this centralized as well. So you could have, you can train locally and share updates with the central server as well. But in our model, this is kind of truly decentralized. But again, if you need someone, for example, to check and validate whether the model updates are good, for example, a regulator, then you may want to do federated learning with a central kind of person in the middle. So of course we've already tried it. So I'll tell you a little bit about why federated learning matters. I think I'd covered some of these things sort of before. So the main benefit is that data never needs to leave its source, right? So you don't often have, it's particularly important when you're dealing with collaboration between countries, especially when you have different regulatory requirements regarding data. Is that if you kind of design, you will need to kind of have some sort of you can have like a very, so in the example that we did today, we sort of trained a model from scratch. We had sort of like started off with a neural network that knew absolutely nothing, and then each one of you trained it, and then it turned out to be a useful model by the end of the exercise, right? So you can create something which essentially becomes compliant by design. The one thing that you do need to, of course, be aware of is that when you are sharing model updates with each other, you do need to look at, of course, how much data is in each training run, right? So, for example, like if you've only got 2 patients' data, in a run, and then you're sharing an update straight after that, then you are creating a privacy risk there, right? So the privacy risk doesn't go away entirely by using federated learning. It enables you to do this while preserving your data, but you need to, of course, kind of adhere to some basic principles to ensure that these benefits are actually upheld, right? So you don't need to worry about organizations refusing to share data. The other key thing is that also it creates a sort of resilience, because there's no single point of failure, there's no single point to breach. The other one of the examples that we're running tomorrow in our office is that we have a bunch of machines which are participating in training run together. One real, like for a bit of drama, what we do is when we do demos is that we literally unplug a machine to show that the system still works, it recovers. So this is particularly useful in countries where you have power issues, power cuts, of course in war situations as well, where models can continue to be useful, can still be trained, you can still run inference without relying on kind of a central system. So health is, of course, the obvious one. That's where we've done the most work. The agriculture is another interesting one. Finance actually was some of the most interesting, actually, because what we often find in the finance sector is that no organization, no bank wants to share their customer data with any other bank, even if it might be helpful to the other one. So this is like a perfect example to dealing with things like fraud. But again, anywhere where governments are worried about their citizens' data being used, right? Because often, you give up data for one use case and another organization or another country may use it for something else. So this enables you to kind of roll out those existing use cases without without anyone effectively giving up their data sovereignty, or even enabling someone to even look at their data. Because I think that was the other thing, is that you can, when you deal with Amazon, when you deal with Microsoft, they will give you agreements that say, hey, we promise to put your data in a separate environment and it'll be encrypted there and we won't have the keys and we won't look at it, etc. Right? Now, you of course have to trust that those central operators will actually adhere to those rules, right? And there may be incentives in very high value cases like defense for one of those operators to break their rules. This way, you're not relying on that trust. You have an absolute technical barrier instead, right? Sorry, Robert, you had your hand up.
Thanks, Mo. That's super helpful, really, to understand. So my question is now, as you are in this field, where do you see the needs are arising for federated learning? And I mean, because also from one side, I can see that, for example, in EU, I don't know how is it UK, but assume similar, there is a more need for this data privacy and all these things. But I don't see this emerging in the States, in China, in Russia, in India, like so. And also, is it, do you see the needs in the future coming from the from private companies if they are pressured, like for example, if there is a pressure on, I don't know, Facebook, on I don't know, like Fortnite, on PlayStation, Sony PlayStation 2, like not to collect data about your kids or players or whoever, right? Is this where we can see this coming? Or do you think it was coming from the governmental sector, or like or is it just, I mean, it's a difficult question, I know, because it's really about the, it's about the political and economical system, right? And not about the, like this is a tool that can be provided, but, like actually what we are seeing is more contrary, right? At the moment, like trying to get, like in Nexus from Harari, like trying to have more control on our data, having more control about us. It's like sadly, we see a lot of contrarian now at the moment.
Yeah, and I think the natural tendency is always to centralize. It's not to decentralize, right? Especially with commercial operators, their ability to target kids and sell them microtransactions or whatever it is the more data you can collect, the more personal that data is, the better it is, right? And I feel that I guess in the UK, in Europe, there is this sort of, I guess there's a general sort of mistrust of government, right? Where people don't want data centralized, and that is bleeding into policy making, into privacy regulation, and that's creating, I guess, the need for these sort of solutions. So, like all of the hospital work we do in the UK is primarily because it is very difficult for those hospitals to do medical research together, to transfer patient data to each other. Now, I think technically it may be possible, but they would have to go through years of safety checks, in order to be able to just get to be able to share patient data, whereas federated learning provides an immediate solution where they can start work tomorrow, right? Whereas when we talk to other countries, they don't have that problem at all. They already have centralized patient records, and they're like, well, we don't need this because we have one database where every citizen's information is there, right? Where we have seen concerns when it comes to sovereignty. So the conversation that we had with policymakers in Borneo, Sarawak is one of the states in the Malaysian Federation. We also had a conversation actually with the head of the National AI Office in Malaysia, and their big concern was, and I think it's partly due to some of the debates they've been having with the US government recently over tariffs and things like that, is that they are actually heavily dependent on American firms, as are quite a few governments, right? A lot of their data infrastructure runs on Microsoft 365. I went to Yifan and I and Vatsal, actually, we went to the National AI Office building in just outside Kuala Lumpur in Putrajaya, right? And we had to register our ID information, our passport numbers, etc., as part of their security checks. They had like a little army post on the ground floor, we had to do those checks. And the first thing that we noticed, when we were entering our information, is that it was on Microsoft 365, right? So all of that data could be copied to the, to the US at any point, right? So the concern that we had from the policymakers there was, if they had some sort of dispute or issue with the US, could those services be shut off? Because, in the case of Amazon, for example, Amazon actually does have a data center within Malaysia itself, but that's not necessarily assurance of sovereignty because the control is not within Malaysia. It's just that the hardware is physically present, right? So, I think, there is this realization now that, when you're dealing with kind of these big state level use cases, you do need to train big models and you do need to run big models. But unless you are, if you go to the Gulf, if you go to Saudi, if you go to UAE, they have sufficient capacity in their budget to spend $500 million, $1 billion to buy all the hardware they need and have sovereign AI that's centralized. Whereas you go to Malaysia or Brazil, for example, South Africa, another country that we were talking to recently, where there are so many other national priorities that to spend $500 million on on a data center, when you've got poverty alleviation and education priorities is a very difficult thing to do, right? And the other key thing with federated learning is also efficiency. So the thing that we had proved in Malaysia last month is that you don't need to buy new hardware. you can still, use these big AI models by slicing these big models down into small little chunks and putting them on existing consumer level hardware that you can buy cheaply, or even better, it already exists, right? There's also a sustainability example here, is that when you've got existing hardware, particularly for stuff running in universities or in office buildings, a lot of those machines are already on. Firstly, you've already acquired them. Often they're already plugged in and they're online. So if you want to, if you want to use them for machine learning tasks, and you're able to distribute or federate your work, the actual power use of an existing office that's already running, like, if you're doing your normal office work, doing emails or whatever, you're not even using 5% of your CPU, but still, like, the whole power footprint is there, right? So you can distribute training across loads of machines and do what would otherwise be quite expensive work without any significant actually increase in your power usage or buying new hardware and things like that. So I think there's a broader efficiency there's a big efficiency kind of benefit, but I think the other key thing is that sort of sustainability and sovereignty benefit. So you don't need to spend $1 billion to get sovereignty. You can just do it with what you already have. But the key thing is, and I think that really kind of concerns us, we heard this fear from the Malaysian government as well, was skills atrophying, because I noticed this. So, I was running innovation for the Royal Bank of Canada, and we had our team across Minneapolis, Toronto, and Kuala Lumpur. What we had found is that after they had adopted some of these cloud providers' tool sets, like, Amazon, right, and Azure in particular, within 1 to 2 years, they had forgotten a lot of those key AI concepts themselves. Like, I'm not forgotten, I'm sure it's somewhere in the back of their mind, but like when these providers put the prices up, it was very difficult for us to unwind those relationships. We would just have to pay whatever bill they put in front of us, because it would take us 6 months, 12 months to rebuild these things. So that's the other key thing to bear in mind, is that, when you use ML, when you use applications built on an AI stack, you have to think about what those dependencies are, and if they decide to, double your bill, is that something you still want to swallow, right? The other thing to bear in mind is that by losing skills, you also lose sovereignty. So, if you've been dependent on these systems for 2 or 3 years, and now the engineers within your country or within your organization can't quickly rebuild these systems, then you're effectively dependent on a vendor. Sorry, Yifan.
Yeah, just I see, is it Robert leaving already? So, but quickly jump in here. There are a couple of items we can look out for. Number one is some government and region have policy or technical paper mandating things like data format. So, for instance, one example here is actually China has one of the most comprehensive data format to mandate what they call trustworthy data space. And in that paper, it's explicitly listed federated learning as one of the use case. So that who's going to implement those paper? That's between hospital and then medical device provider. And in fact, we are engaged in some of those direct technical work with medical data provider and hospital. And the other point that I can just point out a little bit in terms of level of competency, we actually have another conversation with another group of hospital from another country. The origin of that conversation was the individual hospital tried to do federated learning themselves, but they couldn't get it working. So yeah, and they kind of start looking for federated learning vendor. So so there is like a degree of training and enablement here that the Malaysian government and the Sarawak government is already engaged on. But generally speaking, in terms of timeline, we certainly see sort of like level of inquiry pickup after late last year and this year. May or may not have to do with the geopolitical situation.
Almost certainly, I think. Go ahead, Andy.
One point related to the investment in education related to federated learning. Do you have, because this area that now people are envisioning AI, that it's like using LLMs, opening their laptops, and they can, as a superheroes, do everything. Like they can do everything that they want, and then they are hitting a wall with this. Do you see any way of mobilizing resources for such activities related to federated learning, especially to institutions? Maybe this is something that we could explore, because I'm seeing a gap when it comes to hospital. They are thinking that it is more into how we can do this thing, and how we can find a way that it is, we design everything and then it doesn't work. So the institutional investment in this learning, is it available somewhere? Can we maybe explore that and build on this workshop as one of the outcomes to explore how we can find the funding mechanism to such goal with clear partners and everything else, so we can support such thing, because this is what we are looking for in the end of the day.
Yeah, absolutely. So we are actually making our toolkit open source, which means that people can use it kind of without kind of intellectual property sort of concerns. And then part of what we are putting together for the Malaysian government is essentially training material that would embed in their existing program. So I think you will have it across a lot of organizations. There will be training happening on data science and things like that. Some of these, I mean, we've had a look at a bunch of these. Some of them are good because they teach you the key techniques that will work without reliance on any vendors, stuff that you can just do on your own computer, etc. Some of the training is sponsored by the likes of Amazon, and therefore, unfortunately, the Malaysian government has a couple of these courses sponsored by Amazon and by Google, and obviously they teach those techniques, right? But yeah, this is something where I think we have, we should have something ready, basically kind of in the next couple of weeks, where it would just slot into an existing, training course for data scientists or machine learning to kind of say that, hey, if you're following this approach and you have this particular problem where you can't transfer data to a single source, here's a toolkit that you can use, and some sort of information on how to kind of utilize that toolkit. We had to put that together as part of our Red Hat partnership because they require everything to be open source, but also require it to be very well documented so people can learn it very quickly. But I think, yeah, it's something that the response in Sarawak was that it had to be embedded as part of existing training, as opposed to, I mean, it is something that you could potentially do standalone. So if you've got people who've already learned ML, etc., you could probably just do kind of standalone stuff just on FL alone. But I think, as you for states that are a little bit earlier in their journey, it might make sense to embed that as part of a training course from the beginning. Sorry, did that answer your question? Cool, thank you. So I guess now that we've trained a model just now, of course, a very simple model. I will just kind of go through how you kind of put a model through work. So some of you might have heard of the Flock API platform. That's an example of a live service where you've trained a model, but you want everyone to use it. You don't want for it to only be useful on your own machine. So you integrate it into, and so you want it available for everyone within your organization. So you can take a model, you can wrap an API around it, and then make it available across your organization. You only need to do that, however, if this is something that's going to be used by everyone. So you can do kind of the old school method of batch processing, of course. So, if you're only collecting data at intermittent intervals, then you can just simply run, you can train your model on your own device and simply run it on your own device whenever is required, right? So if this is not something that needs to be available to everyone at every time, again, not only does the data not need to leave your device, but maybe the model also doesn't even need to leave your device either. Something that we've been doing a lot of interesting work on is what we call edge deployment. So these are whenever you hear the word edge deployment, this typically means you are going the furthest out away from wherever the center of your organization is, and it usually means when it comes to power, in terms of processing power and also actual electricity use, you're looking at the lowest level. So these are typically so again, in the example of Malaysia, for example, they have a lot of schools which are completely off grid. So you want to ensure your models can run, if you need to run a model at those locations, of course, you need to ensure that it can run on with relatively low power, and that it doesn't need to be. So this is the other thing to bear in mind, is that you don't need to ship a very large model off for every single use case. If you've got some very simple use cases, or you've got some very narrow use cases, even if they're complex, then you can train a model that only deals with that, and then ship off a small device to ship off a small model to whoever your end user is on their end device, and that's how you keep the power and storage requirements down. And of course, models always need monitoring. So this is a useful, again. So I will share this in our group. So you have so you have this whole deck. And I'm sure you would be familiar with a lot of these concepts, right? So, I talked a lot about ensuring you have diversity of data sets. This is really important to kind of ensure fairness, right? So, and again, when you are designing, even with an FL exercise, so for FL, enables you to train without moving data, but you do need to still look at diversity of data and volume of data, because you may be able to break privacy by training on very small sets of data, right? Transparency. So this goes back to what we discussed right at the beginning, is that you don't necessarily need to, the downside, of course, of using machine learning is that you aren't going to be able to explain necessarily logically step by step why a certain decision was made. Ultimately, you are getting an outcome based on probability. But you can still show your stakeholders where you got your training data from, how it was trained, how you did validation. So the way you explain how a model works is really by the outcomes, right? So you pick a varied series of outcomes and you run your stakeholders through that, right? Accountability is very important. So you need to have some way of, you don't want to have these dystopian sort of situation where someone, is declined, the computer says no, and they have no way of reaching a human, right? The real test for a lot of these models is actually being out there in the real world, and you need to have a way where if someone puts their hand up and says, hey, this is not working, that there is a way of coming to the root of that problem, whether it's how the model was trained or how the data was selected, right? We automated an existing process that was already there, but the existing process had people in it that were doing it manually, right? Now, of course, even when you have people doing a process, there are still biases and there are blind spots, but people can be influenced, people can be educated, right? When you replace that with an algorithm, there is no, sort of like when we talked about earlier when we were selecting features, right? There's no common sense, right? So there is no ability for the system to actually put its hand up and say, hey, I'm only giving, all of my customers this month were, from this one place or from this one ethnic group. There's no record of that, right? I mean, there's no ability, when you automate something, for those things to be picked up automatically. So the monitoring is pretty important, but what the mistake that a lot of people make is that when they're monitoring, they're only looking for things which are very obvious. You actually have to learn about the community you're serving and their demographics to actually understand. So in that Los Angeles case, if you had shipped in someone from Kensington to have a, which is Kensington, for those who don't know, is quite a wealthy part of London, right? If you had shipped in someone from Kensington to have a look at that system, they probably would have said there's nothing wrong, right? The only person that was able to figure that out was someone who actually had an understanding of the demographics of that area to look at the outcome of that algorithm and the business decisions that were made and figured out, hey, there is a bias here, right? So that's a little bit more complex, but that's the other thing to bear in mind but I would say that this shouldn't prevent you from using machine learning or even from automating processes, right? It is just something that you have to be aware of. That these, as we already know, these issues already exist with human learning, with human manual processes. So, by not automating something, you are not saving your organization necessarily. You are, if anything, you may be hiding these issues, right? So I guess the key thing is that you do it anyway, right? But make sure you have a monitoring system in place. And often it's only by doing that you will actually learn where your blind spots are. Sorry, Yifan.
I actually have a question for our audience, because you guys are much more in touch in, let's say, some of the more developing countries and African nation, Iraq, for instance. From your point of view, what is the uptake of like AI-driven tool in those countries? Do you see your colleague or your family, your friends already using it to build some app for themselves? Or do you see they're just using it as a chatbot, or do you see they're not using it?
Yeah, I would say mainly the usage of AI, it's linked to LLMs, and
Okay.
it's like the product of LLMs. And this is a big misunderstanding when it comes to the term of AI, which is it is not about opening a product and you are chatting with it and they will give you like the answer for your questions. And this also my problem when it comes to I don't think it's a developing countries problem. It is a general problem even in a very educated community, or as outlined as very educated community. But the main usage is through daily live and search engine usage. This is how I would put it.
Okay.
So yeah, finding information, research, and everything else.
Is there like a cost barrier for them to join? Because in the UK, let's say I pay X, right, Mr. Bus, $20 per month, and I can use this Grok AI. But $20 means a lot more for other nations. So is there like, some country I realize having sort of a national level agreement with Anthropic. Sometimes you see it in the news, although I'm not sure whether it propagated down to the population environment. And in those situations, for instance, do you have regional specific effort to provide large language model service, even via some of the open source alternative? And just to be honest, when we talk about open source alternative, we are talking about Chinese open source alternative here. So do you see those efforts, or do you see that people are sucking up with the Western proprietary API?
Western is more popular, I would say.
I see.
But look, if you are following, for example, the news when it comes to, I think what influenced people to use such models are the storytelling of it. So it's mainly if you find it on the news and you call it ChatGPT, you can notice that some people are using cloud and they call it ChatGPT too.
Yeah.
So it's like it is a storytelling of how these models are solving or trying to solve something, and this would make the argument for Eastern solutions. I wouldn't call it Chinese solutions, but mainly like what comes from the global south or what comes from the eastern side, and even Europe. Even if Manos now gets much more sophisticated when it comes for coders and everything, only the people who are very technical, they know that. Like they can know that Manos is already doing a lot of development. So I wouldn't say it's a Western Eastern, it's an American model that have been dominated the product line, which is, I don't think it represents even like the European way of data privacy, accuracy, traceability, being more ethical when you are using AI, because when it comes to development, it would be more higher when it comes to from US solutions. That's how Genius Act was born, and it's creating more hype than MICA, for example, as if we talk about finance. So yeah, this is mainly what could happen in developing countries. Now, even if you are developing your own app, I think the API integration that you are willing to do is with an American company, you know. So because if your agent or chat box is based on ChatGPT or using cloud or something else, it's the social narrative looks like it's more credible, which is not accurate, but this is like what you have in your mind. Yeah, so that's the main problem. It's a storytelling, language barriers, all of this marketing plan for the models itself. It affect the market as well.
Okay. Interesting.
Yeah.
Interesting. Because I mean, I kind of suspect that's the case, although I would put that with our African-based builder community, it seems to be slightly different. They are a little bit more aware of the other alternative, but again, that's a builder space. So,
yeah.
But you want African builder to be building things for Africa for sure, right? So you want to enable those guys. Yeah.
Of course. Yeah, of course. Like, because I would say it's more into this idea of I would say colonized AI. You know, I would call it colonized AI, which is something. It's following, and I didn't see like many AI builders are really taking consideration of the geopolitical and social anthropological aspects of why you should develop solutions for your continent or your country and everything else. And this is affecting the platform. I don't want to use a lot of time. Maybe we can have the conversation on later stage. But thank you for the question, because we have 4 minutes left. Yeah.
Thank you.
Yes. I think we're right on the last bit now. I think we've kind of covered it actually. So like the key takeaways I guess I want to give you is it's use ML where the problem fits, right? There are other there are much simpler techniques often, and because you can do significant. I think the good thing that the data vendors or the thing that the data vendors are very good at is making you think that you need them, right? And what you often find is that with your 7-year-old laptop, you can actually do something really great that might be enough for your organization, right? So bear that in mind. Data quality always over quantity. So notwithstanding what I said about data volumes earlier, something that you have reviewed yourself that you know is good is better than getting in data from a partner that might give you thousands of records that you're not sure about. Of course, LLMs can help you do everything now. Right? From cleaning the data to actually writing the code. So for your initial experimentation, I think I could quite safely say that you probably don't need an AI engineer or a data scientist. You could have a pretty good crack on your own, I think, with this. And of course, the key thing with federated learning, which is kind of different from the paradigm that we're used to, is that you can actually enable people not to move data around, keep it on their own devices. And I think that should enable us to empower quite a few use cases that we haven't been able to empower before, simply because of political reasons, lack of trust, all of those issues. But yeah, no, that was it from me.
Amazing. It's really eye-opening, like all the information that you shared and the exercise. We are like every session that you bring as Flock, we are more happy to have this kind of collaboration and partnerships, and it's very valuable also for our internal team to really look on what is happening on the tech side and to build the development agenda around it, because if it is the other way around and that we come and we have our own programs and we do, like for example, we want such solutions, I think it's important to understand the basics at least when it comes to the thank you so much, Muhammad, for the very useful information, and for Tiffany and the team. I think it's also Vatsal also, thank you for the exercise. So I would give the floor maybe to Tiffany to the end, and then we can close the session if you want.
Thank you. I actually want to share my screen as well. Wait, if I may share screen. It's a small gift from our team. Can you see?
That's amazing. It's a certificate.
We'll share this in the group.
Amazing. Okay, so we are.
Thank you very much.
Achieved all the. Thank you so much. That was great.
Yeah, thank you. Just let us know if you have any questions.
And of course, we will share the recording with the team. Of course, they will look at it, because it's some of them have different goals or something else. But we are taking these sessions very seriously when it comes to the information in it and to how to design our programs around it, and maybe find another ways of collaboration when it comes to education on federated learning and something, because this is, I think, something that could be discussed on and this explored on how maybe we create a funding mechanism to bring partners around this, and using Malaysia example that you bring, and many other cases that could be explored from this. And also Blockchain for Government Academy, it's called, also be good examples that we bring to the governments there and everything else. Thank you so much for you, the team. Thank you for the certificate, and for Muhammad also for
Please
presenting.
share the certificate in the
job.
social media and tag us.
Of course. Thank you so much.
Thank
you.
You. See you. Have a great day.
Thank you, everyone.
Bye.
Yes, everyone.
Enjoy your day.
Thank you. Bye-bye.
Take care.